Hi guys, I'm back with another video, and today we'll see how to sort using three sorting algorithms. First is the selection sort, bubble sort, and insertion sort. So we'll be discussing these three sorting algorithms in today's video. So first, let's see selection sort. So what does the selection sort say? So to select something, right? So we need to select minimum and then swap it. So this is the main funda of this selection sort. So we need to find the minimum in the array and then just swap it with the current value of I. So what do I mean to say? So let's take an example. So I have this array 13, 9, 8, 7, right? So let's take our I from I equals to 0. So now let's try to find the minimum. So what is the minimum in all of this whole array? 7, right? So what I need to do, I found the minimum and then I'll just swap it. So I'll swap my minimum with this 13 and then move 13 to the place of 7, right? So what would be my output now? 7, 9, 8, 13. So after first swap, I can say that this part of the array is sorted, right? Now I move my I pointer to I equals to 1, right? And then I'll try to find the minimum in this part of the array. So what is the minimum? 8, right? So what would be my output now? I'll just swap this here, move 8 to the place of 9 and move 9 to the place of 8. So it would be 7, 8, 9 and 13. So this is our swap 2, right? So now I can say this part is sorted. Now I'll move my pointer I equals to 2 and try to find the minimum, and I say okay, 9 is the minimum itself, so we don't need to swap. Now we don't need to move further because obviously it's a single element and it would be sorted at its place, right? So we'll run the loop from 0 to n minus 1, not n minus 1, n minus 2. So 0, 1, 2, 3. So we'll try, the length of the array was 4, right? So we ran the loop from I equals to 0 to 2. So it would be n minus 2, which would be 2, right, for us here. So now let's try to write a pseudo code for this. Let's take an example. 13, 9, 8, 7, 6, right? So what is the length of the array? 5. I'll write the indexes, right? I'll take my outer loop. So my outer loop would be running, I said the outer loop would be running from 0 to n minus 2, right? So simply my outer loop will be running from 0 to n minus 2. But I need to find my minimum, right, from 0 to n minus 1. So for when my I was equal to 0, I was trying to find my minimum from 0 to n minus 1, right? Now when I found the minimum and swapped it, so I moved my array element I pointer from 0 to 1. Then I was trying to find the minimum from 1 to n minus 1, right? So simply so if we try to observe, we are basically doing it on basis of the value of I, right? So when I was equal to 0, we were trying to find within 0 to n minus 1. When I's value was 1, we were trying to find the minimum from 1 to n minus 1. So we need to write an inner loop which will give us the minimum in the array, right? So our j will be running from I equals to n minus 1. So basically till this point, right? So let's assume that minimum equals to ith only, I element only. So we'll now compare. If ARR of j is less than ARR of min, then update my min, right? Now once I find out my min, I need to swap it, right, with the current I element. So what I will do, I'll just check first that if minimum is not equal to I, then do a swap, right? Simple for selection sort. Now let's try to write this whole pseudo code in JavaScript using code, okay? So I have this selection sort question here. So we'll try to write the same pseudo code in this. First, I said my ith loop will run from 0 to n minus 2. Okay, so I'll just do if I for I equals to 0, for let I equals to 0, I is less than n minus 1, I plus plus. Then I said I need to run an inner loop to find the minimum. So I'll run a jth loop. So for let j equals to I, j is less than n, and then j plus plus, right? I'll assume there's a minimum. The minimum is I, right? And then I'll do a comparison. If ARR of j is less than ARR of min, then update my minimum, right? So once I find out the minimum, I'll just try to do the swapping with the I element, right? So I'll check first of all if minimum is not equal to j, is not equal to I, then do a swap. So how I can do swap? So I'll just do a simple swapping. So ARR of I comma ARR of min, that is equal to ARR of min ARR of I. So this should do my swapping, and then I'll just return the the sorted array, right? Now let's try to compile this, and then we'll try to do a quick dry run also. So I have this. Let's see if it is giving, yeah, so it's giving us the correct answer. Now let's try to submit and see if all the test cases are passing or not. Yeah, so all the test cases are passing. So now I'll do a quick dry run basis on the what is the example given here. So we have 41397, right? So we have 4 1 3 9 and 7, right? So I'll just do a indexing 0 1 2 3 4. I'll do I, j and the minimum, right? So according to the code that we have written, our I will be first 0, minimum would be 0 2, and j would be running from 0 to less than n, which is this 4 5. First, all will be 0. Now next what we'll do, we'll check if ARR of j is less than ARR of min. So we are here, right? So is it less? No. So we'll move to the next value of j, 1, right? Then we come here. So is ARR of j less than ARR of min? Yes, it is. 1 is less than 4. So we'll update the value of min, right? Now we'll move to the next value of j, 3. Is ARR of j less than ARR of min? Now what is our ARR of min right now? It is 1, right? So is 3 less than 1? No, it's not. So we'll move to next value of j, 9. So is ARR of j less than min? No, it is not. Then we'll move to next value of j. Is ARR of 4 less than ARR of min, which is this 1? No, right? So now we get the minimum as 1. Now what would be our next step? We'll check. We'll come out of this jth loop, and then we'll say is min, if min is not equal to I, yeah, min is not equal to I, then do a swap. So our first swap would be, take another color pen, our first swap would be 1 4 3 9 7. So this is the result of our first swap. Now we'll try to do for next value of I. So I'll just try to, so now we will do it for the next value of I. So what is the next value of I? 1. Next value of min is 1 2, and next value of j is 1 2, right? So this is our I, j and min. and we'll try to find the minimum in this subarray now. Right, now we'll check if is ARR of j less than ARR of min. So what is ARR of j? 4. ARR of min is also 4. Is it less? No, it's not. So we'll move to next value of j, that is 2. Is ARR of j less than ARR of min? So is 3 less than 4? Yes, it is. So I'll update my min, that is 2. Yeah, so my new value of minimum will be 2, that is 3, right? So ARR of min is 3 now. Now we'll move to next value of j, that is 3. 0, 1, 2, 3, 4, right? So I'll check is ARR of j is less than ARR of min? No. Move to next value. Is ARR of j less than ARR of min? No, it's not. So I'll come out of the jth loop. I'll check is if min is not equal to I. Is it? No, it's not. So I'll just do a swap. So my second swap would be 1, 3, 4, 9 and 7. So this is the result of my second swap now, right? So now we will move to the next value of I, that is 2, right? So this is my ith value now. What will be my jth value? It would be 2 as well. Min will be 2 as well, right? We'll assume. Now we will try to find the minimum in this subarray, right? So what we can do, so I'll just check is ARR of j less than ARR of min? No, it's not. We'll move to next value of j, that is 3. Is it like the next ARR of 3 is less than ARR of min? Like 4, 9 is less than 4? No, it's not. We'll move to next value. So is ARR of j less than this, meaning 4 is 7 less than 4? No, it's not. So there would be no swapping here, right? Then we'll move to the next value of I, that is 3. I'll just remove. Right, now we will go for I equals to 3. So what is value of min? 3. Value of j? 3. So it will run from here to here. Fine. So I'll try to find is ARR of 3 less than ARR of 3? No, it's not, because this is that place. We'll move my jth pointer from 3 to 4. Is 7 less than 9? Yes, it is. So I'll update my min value as 4, right? So since jth loop is finished, I'll come out, I'll replace, I'll check is min not equal to I. So it said yeah, so do a swap. So my third swapping would be 1, 3, 4, 7, 9. Now can we say that our array is sorted, right? So this is our resultant sorted array using selection sort. The time complexity of selection sort is O of n square, because we have used 2 loops, so it would be n square. So now let's move to bubble sort. So the funda of bubble sort is you have to move the maximum to the last using adjacent swaps, right? So how we can do that? Let's try to see that using an example. For example, we take an array 13, 9, 8 and 7, right? So if we try to loop, right, so we'll do the adjacent swaps. So we try to move the maximum to the, so basically what is the maximum here? The maximum is 13, right? And I want to move it to the last. So let's try to do using adjacent swaps. So my first swapping would be, I'll just check is 13 greater than 9? Yes, it is. So I'll just create 9, swap it, 9, 13, 8, 7, right? Now I'll do a swap between this two. Is 13 greater than 8? Yes, it is. So I'll just do 9, 8, 13 and 7. Then I'll do a swap between these two, right? So is 13 greater than 7? Yes, it is. So I'll just do 9, 8, 7, 13. So this is swap 1. So can we say that the maximum of the whole array is at the right place, like at the last of the array? So basically this part is sorted now, right? So initially what we did, from 0 to n minus 1. Now we need to do from 0 to n minus 2. So our approach would be from 0 to n minus 2. So first swapping is done till 0 to n minus 1. Now we'll move to using this 9, 8, 7 and 13, right? Now my check would be from these two elements. So is 9 greater than 8? Yes, it is. So I'll just swap it, 8, 9, 7 and 13, right? Now I'll check these two. Is 9 greater than 7? Yes, it is. 8, 7, 9 and 13, right? So after this I don't need to move, right? So because like it's done, so can I say that this part is sorted now after swap 2, right? Now we'll again do the swapping. So I'll check here, 8, 7, 9, 13. So I'll check, is 8 greater than 7? Yes, it is. So I'll just do 7, 8, 9 and 13. So can we say after doing 3 rounds of swapping my whole array is sorted, right? So this is the final sorted array. Now I just need to implement this using code. So before that I need to write a pseudo code. Now can we say that first we need to run the loop, for example, from 0 to n minus 1 for sure, because we need to check, right? So we need to do adjacent swapping, right? So for that we need to run till 0 to n minus 1. So first we did that. Now second, what we did after first swap, if you see, we moved, like we didn't do swapping till n minus 1. Instead we did the swapping from 0 to n minus 2, right? So can we say when the I pointer moves from 0, we did swapping from 0 to n minus 1. Now if I move the I pointer to 1, right, can we say we need to do from 0 to n minus I minus 1, that is n minus 2, that we did here, right? We didn't go like further this element, right? We did just till here, right? Can we say if I go from I equals to 2, my swapping would be done from 0 to n minus 2 minus 1, that is n minus 3, right? For this also if I go, so because this part was sorted, I just did till here, right? N minus 3. So my inner loop will run from 0 to n minus I minus 1, and I'll just compare that if ARR of j is greater than ARR of j plus 1, simply swap it, right? And then it will implement our bubble sort. Now let's try to do the same thing in code. Okay, so we have been given an array 41397 and we have been given 2 examples, and we need to sort these 2 arrays using bubble sort. So we have been given an array and the length of the array. So in my pseudo code we said that I'll run the loop from 0 to n minus 1. Okay, so my outer loop will run from 0 to n minus 1, right? And then I said my inner loop will run from 0 to n minus I minus 1. Okay, so for let j equals to 0, j is less than or equal to n minus I minus 1 j plus plus Now I'll compare. If ARR of j is greater than ARR of j plus 1, then just simply swap. So ARR of j, ARR of j plus 1 equals to ARR of j plus 1 comma ARR of j, right? And then I'll just simply return the array after being sorted. Let's see if it is working or not. So yeah, it's working for this array. Let's try to see other test cases as well. Yeah, so all the test cases are passing. So what is the yeah, so the time complexity for bubble sort is also O of n square, since we are using two loops here again, right? Now, okay, so the next sorting algorithm is insertion sort. So what does this insertion sort do? So it moves the element. You need to move the element until it reaches its correct position. So let's try to see insertion sort using an example. 13, 9, 8 and 7. How would the sorted array look like? 7, 8, 9 and 13. Right? Now what I will do, I'll keep on checking until all the elements are at its correct position, right? So we'll go for 13. So since it's a single element, so it's sorted. We'll move to next. So next subarray would look something like this. So I'll check with the previous element, is it like greater? So it says yeah, it is greater. If it is greater, then I'll do a swap, right? Then my array would look something like this: 9, 13, 8 and 7, right? Then I'll increase the length of my subarray to this, right? So if we see, the elements are not at its correct place. So this 8 should be here, 9 should be here and 13 should be here, right? So we'll do one by one. So we'll compare, is 13 greater than 8? Yes. So basically the I minus 1th place is greater than ith place, right? So we'll move 9, 8, 13 and 7, right? Then again I'll check, is I minus 1 greater than I? So I say yes. So it will look something like 8, 9, 13 and 7, right? So according to the subarray, these all elements are at its correct position now. Now we will increase the size of the subarray again. So it would be here. So if it would be like this. So how it should be sorted, it should look something like 7, 8, 9, 13, right? So again we'll do the comparison. Is I minus 1 greater than I? Yes, it is. So now how it will look? 8, 9, 7, 13. Then so now I'll compare with I minus 1 again. 8, so it is greater, right? So I'll do a swap again. 7, 9, 13. So I'll do a swap only if I minus 1 is greater than I. Then I'll do a swap, right? So we'll see this. Is it greater? Yes, it is greater. So my final would look something like this. Now all the elements I can say are sorted, right? If you're not understood using this, so let me try using uh, a pseudo code. So what I did, I tried to create subarrays, increase the length of the subarray one by one, right, until unless all the elements are at its correct position, right? So let's say my I would go from 0 to n minus 1, right? So my outer loop will go from 0 to n minus 1. Now what I had to do, so if you see, for the first element I didn't do anything. So let's say I'll run a inner loop, right? So for first I didn't do anything, but I did when I minus 1 element is greater than I element, then I was doing a swap, right? So let's store this value of I in the j variable, say j equals to I. So I'll do a swap when j is greater than 0, and ARR of j. So I'll do a swap when j is greater than 0 and j minus 1, a of j minus 1 is greater than a of j. Then I'll simply do swap and then I'll decrease the value of j minus minus so that all elements are at its correct place, right? So this is the pseudo code. We'll try to do a dry run also after we write the code in JavaScript. So let's try to write the code in JavaScript for insertion sort. So what I did, I ran a loop from I equals to 0, I is less than n, I plus plus. Then I need to run a j loop that will have the same value as I. So let j equals to I. Now I'll run j loop until j is greater than 0 and ARR of j minus 1 is greater than ARR of j. Then I'll do a swap. So ARR of j, ARR of j minus 1. I'll just do a swap. ARR of j minus 1, ARR of j, right? And then I'll just simply decrease the value of j and I'll return the array. Let's try to compile. Okay, working. Let's try to submit. Yeah, working for all the test cases. Now let's try to do a dry run for an example. So we have an array 4, 1, 3, 9 and 7, right? I have I and j, right? So 0, 1, 2, 3, 4. So what is the length of the array? 5, right? I'll do array indexing from 0, 1, 2, 3, 4. Now what did I say? My I will run from 0 to n minus 1, right? So my I will be 0 and in the code I said so j equals to I and j should, like a loop should run while j is greater than 0 and a of j minus 1 is greater than a of j, then swap and then decrease the value of j, right? So this is the code what we have written and then we'll do the dry run for this array. Okay, so we have I equals to 0. So in the code I said j equals to I, so j would be equal to 0 to, so what this condition say, j is greater than 0. Is my j greater than 0? No. Then I'll go to 1, right? J equals to I, fine. While j is greater than 0, yes, it is greater than 0. And I'll check, is a of j minus 1 greater than a of j? So I go here. So this is what it found, right? A of j minus 1. What is a of j minus 1? 4. A of j is 1. So is it greater? Yes, it is. So I'll just do a swap. So 1, 4, 3, 9 and 7, right? And then it says j minus minus. So 0. Right? Then again it comes back, is j greater than 0? So no, it's not greater than 0. Then I'll increase the length of the subarray. How? Increase the value of 1. Now what I did, I increased the value of I by 1, right? Now again j equals to I, so j would be 2, right? Now I'll check, while j is greater than 0, yes it is, a of j minus 1 is greater than a of j. So I'll just do indexing. So this is a of j, right now. So is it greater? Yes, it is greater, right? 4 is greater than 3. So just do a swap. I'll say okay, I'll do a swap. 1, 3, 4, 9 and 7, right? And then simply decrease the value of j. I'll say okay, it would be 1, right? Again I'll do the same logic. J is greater than 0, yes. Is a of j minus 1 greater than a of j? No, it's not. So I'll just come out of this loop. Now I'll increase the value of I to 3. So 2, 3. So this is my I now, right? Again I'll do the same logic. So it is 3 now. Is it greater than 0? Yes. A of j minus 1 greater than j? No, it is not, right? So it's not, so we'll not do anything. Now I'll increase the value of I to 4, right? This one. Then I'll again do j equals to I. Yes. Then I'll check j is greater than 0. Yes, it is. Is j of minus 1 greater than a of j? So if we see, yes, it is, right? A of j minus 1, it's 9. 9 is greater than 7, right? Now how will be my array looking? 1, 3, 4, 7 and 9, right? Now we don't have anything, so I'll just do j minus minus 3. So my j comes here. Is it greater? No, nothing is there. So this loop will not, like, it will not get executed. Then I'll come out. So my loop will stop here because we have traversed through the whole array now, and then we finally get the sorted array. So this is how you can do sorting using insertion sort. Okay, so the time complexity of insertion sort is O of n square, because we are running two loops here. One is from 0 to n minus 1 and the second is from I equals to I to 0, right? And the space complexity would be O of 1 because we have not used any extra array. We are just doing it at that place. So we have gone through three sorting algorithms. One was your selection sort, insertion sort, and bubble sort, right? If you like this video, then click on the like button and subscribe to my channel for more such videos. I'll be coming up with two other sorting algorithms, that is merge sort and the quick sort, which are more optimized version of sorting an array. So make sure you subscribe to my channel and stay tuned for more upcoming videos.